So let's solve this last set of examples, and then I give you a trial questions to solve. The first set of example is that we should find the integral of 1 over x plus 3 dx, or dx over x plus 3. This can also be rewritten as integral of 1 over x plus 3 dx. They are all the same. So in doing this, you can say that let your x or your u is equal, let me bring down here, let your u to be equal to x plus 3, and therefore your du dx is equal to 1. As I said earlier on, this 1 is the derivative of x, and therefore it will be good for us to do use substitution. Assuming that this top here is x, let me write here. Let me do here. No, it seems it's not working well. Assuming that this top here is x. If this top here is x, this one is not the derivative of x here. Since it's not the derivative of x, when you use substitution, still now you will not be able to eliminate this x value here, and therefore the use substitution will not be necessary. But assuming that if this one becomes x and then the denominator also becomes x squared, you can see that this one is the derivative of x squared, but just that the constant will come in, and if constant come in, we are okay with it. We can bring it outside and do our integration, and therefore we are good to go, or you are good to use the use substitution to do it. So in this case, we are not having a numerator of x squared, and we are not having numerator of x, and we are not having denominator of x squared. We are having numerator of 1 and denominator of x plus 1, and therefore we can use the u, which is x plus 3, and then our du over dx equal to 1. So making the x the subject, we are going to get du over 1, which is the same as the u. Therefore we can replace it in the question. So the question becomes, or let me bring it down here, the question becomes integral of 1 over u. And then when we replace this one by this, we are going to get the u. And we all know this one, that ln of x differential is 1 over x. Therefore, integral of 1 over u is what? Ln of what? U. And then don't forget your integration constant, which is c. And then when you are done, you need to replace this one. You are going to get ln x plus 3. Now ln x plus 3 and then plus c. So this is what we have for this first question. So let's look at the second question. The second question says that we should find x integral of x exponent x squared. When you observe this one, you can see that this x here is the derivative of x squared here, which is the power of the exponent, and therefore using use substitution can work perfectly to help us eliminate this value of x, or this x over here. So in doing so, we can say that let our u equal to x squared, and therefore our du dx is equal to 2x. Making the x the subject, because remember that there's a dx here, there's dx here. I forgot to bring it. So we can make the x the subject, and when we make the x the subject, we are going to get the x equal to du over 2x. The next thing is to do substitution, but remember that after letting u equal to x squared, your function changes to become x exponent u dx. So when you do the substitution over here, we are going to get integral of x exponent u du over 2x. This is similar to what I was saying earlier on, because the constant will be the one which will be the difference, and we can bring it out to do our integration. So we know that x is common here, so it will cancel out. And at the end of the day, we are going to get the integral of exponent u over 2 du. So from here, we can bring the constant out, which is 1 over 2, multiplied by the integral of exponent u du. We all know that integral of exponent u or exponent x is the same function, and therefore we are going to get exponent u plus c. Don't forget that we have a multiplication of 1 over 2. So when you get something like this, whatever you need to do is to then replace the u back, and we know that we are going to get 1 over 2, which is 1 over 2 exponent s squared plus c. So this will be your final answer for this type of question. So you can see this is as simple as that. Let's look at our last question. And our last question is that we should find the integral from 0 to 1 of 5x square root of x squared plus 3 all dx. You can see that this is not an indefinite integral. This is a definite integral with a limit being given, which is integral of 0 to 1 5x square root of x squared plus 3 dx. So based on this, per normal observation that we do always look out for the fact that you are going to get a function and its integral, right? So when you look at this function, you can see that this is the derivative of this, and therefore we can eliminate this one here to get a simpler function when we use u substitution. And this confirms that our u substitution will be easy for us to use. So in doing so, we can say that let our u equal to x squared plus 3. And we want to replace this as well, because at the end of the day, when you make it let u equal to x squared plus 3, the function changes to become u 0 to 1 5x square root of u dx. We want to integrate it with respect to u, therefore we need to replace the x. And since we have our u here, we can say that our du dx is equal to 2x plus 3 or plus 0, because when you differentiate 3 we get 0, and therefore finally we are going to get 2x. When we get 2x, we can make the x the subject. When we make the x the subject, we are going to get du over 2x. When we get du over 2x, we can just replace it over here. When we replace it, we are going to get integral from 0 to 1 5x square root of u and then du over 2x. So x is common over there, so we can cancel x out and our function becomes simpler, which is 0 to 1 5 over 2 square root of u and then du. Now we have everything in one variable. We can bring the function, the constant out, which is 5 over 2, and then integral of 0 to 1 square root. And we know square root of u can also be written as u power 1 over 2 du, and from there we can use our power rule to find the integration. And use the power rule to find the integration, we are going to get 5 over 2, then multiply by u power 3 over 2, because when you add 1 to it, 3 over 2, and then here becomes 3 over 2. So at the end of the day, remember that we have a limit. So since we have a limit, we don't have to integrate and include the integration constant. So we have a limit from 0 to 1, and per simplification, we are going to get 2 over 3 u power 3 over 2. And then we are going to get from 0 to 1. So having this simplification, if you want to use u directly by inserting these ones inside, then you need to do a bit calculation over here, because our u equal to x squared plus 3. If you want to use this limits directly into this u, then put those limits inside this function to get new values of u. I'm going to do them so that when we are done, I will use the other method for you to get whatever we are going to get. So having this, I need to do some change of limits. So at 0, we can say that our u1 or u lower equal to 0 squared plus 3. And therefore our u1 equal to what? 3. Or our u lower. Then our u upper is equal to 1 squared plus 3, which is equal to 4. Therefore, you can say that this 2 over 3 u power 3 over 2, you can also write it as 3, 4. And from here, you can substitute it directly, which is what? 2 over 3, and then 4 power 3 over 2 minus 2 over 3, and then 3 power 3 over 2. This is upper limits minus lower limits. So now let's see what this one have for us. So this is 4 power 3 on 2. And then we are going to get something like 8. And then 8 times 2 will give us 16 on 3. Minus 3 power 3 on 2. 3 on 2. We are going to get 5.196. Then multiply by 2 on 3. We are going to get 3.46, which is what? 3.464. So subtracting this one, 16 over 3, minus this 3.464, what are we getting? Let's see what we are getting over here. Let's see what we are getting over here. Oh, yes, but don't forget that I've left this 5 over 2 out, so let's take note of that as well. So don't forget that here it's also 5 over 2. Here it's also multiplied by 5 over 2 yet. So whatever you are getting here, going to 5 over 2. And then here will be also 5 over 2. So now 5 over 2 multiplied by 16 over 3. And then you are going to get something like 13.33 minus 3.46 multiplied by 5 on 2. we are going to get something like 8.64, which is 8.6, let's say 5. So subtracting these two, which is 13.33 minus this 8.65, we are going to get 4.68, which is what? 4.68. Now this is what we have. Let's use the other method as well. Now here we did change of limits by substituting the initial limit inside to get a new limit. But if you want to use the given limit which was given in the question, just substitute the u back. So when we substitute the u back, we are going to get this 5 on 2, and then we have our 2 on 3, and then our u 8x squared plus 3, and then when we are done, it's power 3 on 2, and then the limits are from 0 to 1. So when we put it in 1, it's upper limit and lower limit. So we are going, these two cancel these two here, right? For example, 5, let's not cancel it first. Let's kind of work a bit so that you will not be confused. So now we can say that this one, when we multiply it, what are we going to get? Or let's move it on first and before we come here. Now from when I put it when I'm in 1, I'm going to get 2 over 3, 1 squared plus 3, all power 3 on 2, minus 5 on 2, also here, 2 on 3, 0 plus 3, all power 3 on 2. You can see here. You can see that this is somehow similar to whatever we did earlier on, because here we are going to get 4, here we are going to get 3. When we were doing it here, you can see that we got 4 over here, we got also 3 over here, and then we have our, as usual, 2 over 3, 2 over 3, and then multiply by 5 over 2, 5 over 2. This is something similar that we are getting here. And at the end of the day, we are also going to get 4.68. So you can see that any of them can work. So it's just a matter of choosing the one that you'll be comfortable working with. But please, if you want to work with u, make sure you do the change of subject first, or the change of limit first before you proceed. If you want to work with the x values, then bring back the u representation, which is x squared plus 3, and then substitute in the given limits. So to end this tutorial, I would like to give you some couple of examples for you to try. One example that I want you to try is the integral of 6x squared over 7 over 3 plus 2x power 3, and then I have dx. This is one example. And then another example that I want you to also try, it's integral of 4x 2x squared plus 3 power 3 dx. And the last one, this is 1, this is 2. And the last example that I want you to try is the integral of exponent x over 1 plus exponent x dx. So don't hesitate to try your hands on these ones and then see how well you understand this topic. So thank you for watching, and see you in my next